The Yamato was the largest and most heavily armed battleship ever constructed, a warship designed during a period when naval doctrine still believed that massive guns and heavy armor would decide control of the oceans. Built by Imperial Japan during the Second World War, the Yamato represented an attempt to counter the industrial strength of the United States by creating battleships so powerful that no opponent could challenge them directly in a conventional surface engagement. At the time of its construction, Japan understood that it could not realistically outproduce American shipbuilding capacity. Instead, Japanese planners pursued qualitative superiority, believing a smaller number of overwhelmingly powerful warships could offset numerical disadvantage. Physically, the Yamato was enormous, even by battleship standards. The vessel measured approximately 263 meters in length, with a full load displacement exceeding 70,000 tons. Its armor protection was among the heaviest ever placed on a warship, designed to withstand direct hits from large-caliber naval guns at long range. The most distinctive feature of the ship was its main battery of 9 46-centimeter guns, the largest naval artillery weapons ever mounted on an operational warship. These guns were capable of firing massive armor-piercing shells over extreme distances, giving the Yamato theoretical superiority against any contemporary battleship. Power was provided by steam turbines, producing enough output to move the enormous vessel at speeds exceeding 27 knots. Although slower than some smaller warships, the Yamato combined firepower, protection, and range in a way few ships of its era could match. Internally, the ship was designed to survive catastrophic damage through extensive compartmentalization and defensive systems intended to resist torpedo attacks and flooding. The battleship reflected a naval philosophy built around decisive fleet engagements, where heavily armored surface combatants would destroy enemy fleets through direct confrontation. However, the Yamato entered service at a time when naval warfare was changing rapidly. Aircraft carriers, naval aviation, and submarine warfare were beginning to replace battleships as the primary instruments of sea power. Despite its immense size and firepower, the Yamato spent much of the war operating cautiously due to the growing threat posed by carrier-based aircraft. Its eventual destruction in 1945 by large-scale American air attacks demonstrated that even the most heavily armed battleship in history could be overwhelmed by coordinated naval aviation. In many ways, the Yamato did not just represent the peak of battleship development, it also symbolized the end of the battleship era itself and the transition toward a new form of naval warfare dominated by aircraft carriers and long-range air power. The USS Virginia is the lead vessel of the Virginia-class attack submarines, a class designed to replace older Cold War-era submarines while adapting to a very different type of naval warfare. Unlike earlier submarines built primarily for open ocean confrontation with rival superpowers, the Virginia was developed for a wider range of missions that included intelligence gathering, special operations support, precision strikes, and anti-submarine warfare. Its design reflects the modern reality that naval conflict is no longer limited to deep ocean engagements far from shore. Instead, submarines are now expected to operate close to coastlines, monitor hostile activity in contested regions, and support both conventional and covert military operations simultaneously. Physically, the USS Virginia is smaller than some previous American attack submarines, but its reduced size does not represent a reduction in capability. The submarine measures approximately 115 meters in length, with a submerged displacement of around 7,800 tons. Powered by a nuclear reactor, it can remain underwater for extremely long periods without refueling, limited more by crew endurance and supplies than by propulsion requirements. Speed remains classified, but the submarine is capable of sustained high-speed underwater movement while maintaining a very low acoustic signature. Quiet operation is one of the defining characteristics of the Virginia-class design. Advanced sound isolation systems, improved hull construction, and modern propulsion technology make the submarine significantly harder to detect than many earlier attack submarines. The submarine's combat systems are centered around flexibility rather than specialization. The USS Virginia is equipped with Tomahawk cruise missiles capable of striking targets hundreds of kilometers away, allowing the submarine to engage land-based infrastructure while remaining hidden underwater. For underwater combat, it carries heavyweight torpedoes designed to destroy both enemy submarines and surface warships. Its sonar systems are among the most advanced in the Navy, optimized to track hostile submarines across both deep ocean and shallow coastal environments. This emphasis on anti-submarine warfare reflects the continued importance of undersea dominance in modern naval strategy. One of the more unusual aspects of the USS Virginia is its ability to support covert operations. The submarine includes a lockout chamber that allows Navy SEALs and other special operations forces to deploy underwater without surfacing. This capability transforms the submarine from a conventional attack platform into a tool for intelligence collection, reconnaissance, sabotage, and clandestine insertion missions. The Virginia's ability to combine stealth, strike capability, surveillance, and special operations support within a single platform is what makes it one of the most important components of modern American undersea warfare doctrine. The USS Enterprise was the world's first nuclear-powered aircraft carrier, and its introduction marked a structural shift in how naval power projection was understood. Before its construction, aircraft carriers were already central to naval strategy, but they were still constrained by conventional fuel logistics, limiting their endurance and operational flexibility. The Enterprise changed that baseline completely by introducing nuclear propulsion to a full-sized carrier platform, allowing it to operate for years without refueling. When it entered service in the early 60s, the USS Enterprise was not just a larger version of existing carriers, it was a completely different operational concept. The ship measured over 340 meters and displaced more than 90,000 tons, making it one of the largest warships ever built at the time. But its most defining feature was not its size, it was the nuclear propulsion system, consisting of multiple reactors that provided virtually unlimited range. This meant the carrier could remain deployed in critical regions for extended periods without the logistical interruptions that conventional carriers required. In practical terms, it transformed the idea of naval endurance from weeks or months into a near-continuous global presence. The Enterprise was designed to carry a full complement of carrier-based aircraft, typically including fighter jets, attack aircraft, reconnaissance platforms, and early warning systems. This air wing allowed it to conduct a wide spectrum of missions ranging from fleet defense to deep strike operations against land targets. The carrier functioned as the center of a carrier strike group, coordinating with destroyers, cruisers, and submarines to form a multi-layered combat formation capable of operating independently in contested regions. What made the Enterprise particularly significant was how it influenced naval doctrine. Its nuclear propulsion eliminated the traditional dependency on frequent refueling, which in turn allowed carrier groups to operate with far greater strategic unpredictability. Naval planners could now position strike groups in remote regions for extended deterrence missions without the same logistical footprint that had previously limited deployment duration. This shift changed how global naval presence was maintained during the Cold War, especially in areas where sustained visibility was a strategic necessity. The ship also served as a testbed for integrating nuclear propulsion with large-scale aviation operations at sea. Lessons learned from its design and deployment directly influenced subsequent generations of carriers, particularly in terms of reactor design, onboard systems integration, and long-term maintenance cycles. Even as newer carriers replaced it operationally, the Enterprise remained a reference point for what nuclear-powered naval aviation could achieve. Its legacy lies not only in its capabilities, but in how it redefined the operational limits of naval air power and permanently expanded the concept of sustained global maritime presence. The HMS Dreadnought was a battleship developed by the British Royal Navy during the early 20th century, at a time when major powers were competing for naval dominance on a global scale. Before its arrival, battleships were built around mixed-caliber weapon layouts that combined large guns with smaller secondary batteries intended for shorter-range combat. The Dreadnought completely abandoned this approach. Instead, it introduced an all-big gun configuration centered around heavy long-range artillery, fundamentally changing how naval warfare was understood. The moment the ship entered service in 1906, nearly every existing battleship in the world became strategically outdated, regardless of age or condition. The Dreadnought was designed around the belief that future naval engagements would occur at much greater distances than previously expected. Advances in fire control systems and naval gunnery made long-range combat increasingly practical, reducing the importance of smaller secondary weapons. To exploit this shift, the ship carried 10 12-inch naval guns arranged in multiple turrets capable of delivering concentrated firepower against enemy vessels that extended range. This configuration simplified targeting and increased offensive effectiveness compared to earlier battleships that relied on mixed gun calibers. Physically, the ship measured approximately 160 meters in length with a displacement of over 18,000 tons, making it one of the most powerful warships of its era. Armor protection covered critical sections of the hull and gun positions, reflecting the expectation that the vessel would engage enemy fleets directly in major surface battles. Power was provided by steam turbine engines, another major innovation at the time. Unlike older reciprocating engines used by earlier battleships, steam turbines gave the dreadnought greater speed, smoother operation, and improved mechanical efficiency. The ship could achieve speeds exceeding 21 knots, allowing it to outmaneuver many contemporary battleships while maintaining heavy firepower. What made the dreadnought historically significant was not simply its individual performance, but the global reaction it triggered. Naval powers including Germany, the United States, Japan, and others immediately began constructing similar battleships in response. Entire fleets that had taken decades to build were suddenly considered obsolete because they could no longer compete with the new standard established by the dreadnought. This accelerated a naval arms race that increased international tensions in the years leading up to the First World War. In practical terms, the ship reshaped naval strategy, shipbuilding priorities, and military spending across multiple empires. The term dreadnought itself eventually became synonymous with an entire generation of battleships, demonstrating how one warship permanently altered the direction of naval warfare. The USS Zumwalt is a guided missile destroyer developed by the United States Navy as part of an effort to redesign surface warfare for the modern era. Unlike earlier destroyers built primarily around traditional fleet escort roles, the Zumwalt was designed with a heavy emphasis on stealth, automation, and long-range precision strike capability. Its appearance alone immediately separates it from conventional warships. The ship uses a tumble-home hull design in which the sides slope inward rather than outward, reducing radar reflections and making the vessel significantly harder to detect. According to the Navy, the radar signature of the Zumwalt is comparable to that of a small fishing vessel despite the ship's actual size. This represented a major shift in naval design philosophy, particularly for large surface combatants that had traditionally prioritized visible firepower and armor over concealment. Physically, the Zumwalt is the largest destroyer currently operated by the Navy. The ship measures approximately 190 meters in length, with a displacement exceeding 15,000 tons, making it considerably larger than many previous destroyer classes. Its angular superstructure and enclosed systems were designed to minimize both radar and infrared signatures while improving survivability in contested environments. Unlike older warships that depended heavily on large crews, the Zumwalt incorporates extensive automation systems that reduce manpower requirements while streamlining internal operations. This reflects a broader trend toward digitally integrated naval platforms capable of operating with smaller crews and greater system coordination. The ship was specifically designed for littoral warfare, meaning operations conducted close to shorelines and coastal regions. In these environments, stealth becomes particularly important because warships are more vulnerable to land-based missiles, aircraft, and surveillance systems. To support ground operations, the Zumwalt was equipped with the Advanced Gun System, a long-range naval artillery platform capable of firing precision-guided projectiles against targets over 70 nautical miles away. This capability was intended to provide sustained fire support for amphibious assaults and coastal strike missions while keeping the ship outside many defensive engagement zones. One of the most important features of the Zumwalt is its integrated power system. Rather than relying on separate propulsion and electrical networks, the ship uses a fully electric architecture capable of generating enormous amounts of onboard power. This system was designed not only for current combat requirements, but also for future technologies such as electromagnetic railguns and directed energy weapons, including lasers. In many ways, the Zumwalt represents a transitional warship, bridging conventional missile destroyers and the next generation of naval combat systems. Its combination of stealth, automation, precision strike capability, and scalable electrical power reflects how modern naval warfare is increasingly shaped by detection management, long-range targeting, and advanced energy-based weapon systems, rather than traditional naval gun battles alone. The USS Ronald Reagan is one of the Nimitz-class supercarriers, a class of warships designed to function not simply as naval vessels, but as fully mobile air bases capable of operating across entire regions without relying on foreign territory. Entering service during the early 2000s, the Ronald Reagan represents the continuation of an American naval doctrine built around carrier strike groups and long-range power projection. While newer Ford-class carriers introduced updated technologies and automation systems, the Ronald Reagan remains one of the most important operational carriers in the United States Navy due to its reliability, endurance, and ability to support sustained air operations far from home waters. Physically, the carrier is enormous. The ship measures approximately 333 meters in length, with a displacement exceeding 100,000 tons when fully loaded. Its flight deck is designed to support continuous launch and recovery operations under demanding combat conditions. Unlike smaller carriers operated by many other nations, the Ronald Reagan can carry more than 70 aircraft simultaneously, giving it the ability to perform air superiority missions, strike operations, reconnaissance, electronic warfare, and airborne command coordination from a single platform. Aircraft typically assigned to the carrier include the FA-18 Hornet and Super Hornet, EA-18G Growler electronic warfare aircraft, and the E-2D Hawkeye airborne early warning platform. Together, these aircraft create a layered combat capability that extends far beyond the carrier itself. Power is provided by 2 nuclear reactors, allowing the ship to remain at sea for extremely long periods without refueling. This nuclear propulsion system gives the carrier strategic flexibility that conventional warships can't easily match. Rather than depending on nearby ports or fuel infrastructure, the Ronald Reagan can remain deployed in critical regions for months while sustaining continuous flight operations. This endurance is central to its mission profile, particularly in areas where rapid military response or persistent presence is considered essential. The carrier rarely operates alone. Instead, it functions as the centerpiece of a larger carrier strike group composed of guided missile destroyers, cruisers, submarines, and supply vessels. These formations are designed to protect the carrier while extending its offensive and defensive capabilities across sea, air, and undersea environments. In practical terms, the Ronald Reagan serves as both a command platform and a mobile concentration of military force capable of influencing conflicts without requiring permanent bases nearby. Its continued relevance demonstrates how aircraft carriers remain central to modern naval warfare, despite the growing threat posed by missiles, submarines, and advanced anti-ship weapons.